Hello everyone, this is Rajesh Pichaimani and I'm a solutions architect at Amazon Web Services. In this session, we are continuing our security baseline workshop of part 2. A couple of months ago, the part 1 was published and we are continuing this series. In the interest of time to keep the session short and succinct, I have broken down the part 2 into two subparts, part 2A. That's what we are going to talk about. We're going to see what the scope of this session is, which is focused on securing the workload, and then have a hands-on view of the part 2, which focuses on the level 1 and level 2 content within part 2, and finally conclude with the references. Just to recap, the workshop is, the links will be provided in the references section as well as in the description of the video. So here we are going to focus on this securing the workload as part 2 series. And the content of these 4 of them are quite long. So I have broken down into 2 again. So level 1 and level 2 will be covered in this session, followed by level 3 and level 4 in the subsequent one as part 2/B. Okay. So what is covered here in level 1? This level 1 is focused on the IAM related permissions, the importance of roles over users. We'll talk about the secrets manager service, parameter store, and finally some references and resources of how to prevent the application secrets being exposed. In the level part 2, in the level 2, we focused on protecting the data. How we are going to protect the data in S3 service, how we are going to track them, what are some of the ways to protect in the EC2 instances, especially focused on the EBS volume, obviously, and in the database data as well. And finally, some resources that focuses on the importance of data encryption in transit. So let's get this started with the demo. I'm going to switch to the console in just a second. As I mentioned here, this is the homepage for the Security Baseline Workshop. We have covered part 1 in the previous series, and here we are in part 2, securing the workload. Like I briefly mentioned, this focus will be on level 1 and 2. Okay. In this level 1, as you're seeing here, this focuses on the emphasis of using roles instead of users. And there are different types of roles that can be used attached to EC2 instances, Lambda functions, containers, and ECS. So let me walk you through what has been outlined in this workshop in a hands-on mode. I'm in the home page in the identity and access management on the management console. I've clicked roles here. And within roles, I have chosen a subset focused on filtered view of anything that starts with EC2. So if I remove this, it lists all the roles starting in the alphabetical order. But in the interest of this focus of this workshop, I'm going to focus on a couple of things that was already created to illustrate the workshop contents. Okay. The first one is the EC2 role, the role that can be attached to any EC2 instance. Keep in mind, these roles can be even attached after the creation of the EC2 instance. There are a couple of them for illustration, for examples here. Let me quickly open one of them. So this is EC2 Linux IAM role. We have some policies attached to this role. Like as you're seeing here, for that EC2 can communicate with S3 and also the SSM managed instance core. So having this policy will help you to use session manager to communicate with the EC2. In here is a little bit more permissive. The EC2 read-only access, just the read-only access for S3 that the EC2 can attach to. By this time, you can also do some additional ones related to ECS as well, Elastic Container Service. There are two parts in the Elastic Container Service. Either you can have a EC2 instance type or Fargate type. In the EC2 instance type, you will be using a role called EC2 instance role. ECS instance role, which will have this policy attached to it. Amazon EC2 container service for EC2 role. And you will use this and attach to the EC2 instance that are created as a part of the Elastic Container Service cluster. Okay. And for roles which for ECS with Fargate type, you will have task execution role that will be attached to the tasks like the one shown here. So the permission policy that you need for this purpose is ECS task execution role policy. Okay, so depending upon the type of services that you're going to attach, whether it can be to EC2, ECS with Fargate type, ECS with EC2 instance type, or even Lambda, right? So Lambda S3 read only, which means that this service, this role was attached to a Lambda function that will talk to S3 in a read-only mode. Okay. So these are some of the examples of the roles that can be attached to commonly used services. Now that we have seen what was already created, let me give a quick walkthrough of how it can be created. Again, there are different options in this role, but I'm going to keep it with the focus on AWS service. With this, you can pick and choose the commonly used services, whether it is EC2 or if it is container service, you choose containers. Like as I mentioned, it can be of Fargate type or EC2. If it is of Fargate, then you use container service task, or this is for the EC2 instance type. Okay, or you can choose Lambda. By choosing this, what happens is, let me show you one example here. Just a second. It will create a role. You can think of this object as two arms to it. One is this role. Who can assume this role, right? That's a trust relationship. Means this role can be assumed by someone to execute the task. What is that service? And that's what is Lambda service. That's why we chose in the first menu, we chose AWS service as Lambda. When you choose Lambda, this trust relationship information is already pre-populated because we are telling Lambda should be using this role. And that's a trust relationship. Who can use it? The other side of the role is once Lambda takes this role or assumes this role, what can it do? And that's given by the instruction in the permission policy, permissions. So right now we have chosen this S3 policy. which says allow your all actions. This is one example of using a user created policy, but it can also be already a pre-created one. So add permission policies, and anything with this orange box is a AWS managed policy, or it can be a one that you have already created. So both options are possible. So that's a summary of this example of having a Lambda role created and attached it. If you want to have a different service that needs to be used by this role or assumed by this role, you can edit it and give the service name in the principal category. So it can be any AWS service for your use case that needs to be assuming this role. Okay. So that's a quick run through of the first action, first item, IAM roles. Next comes the parameters. This is a way of having a credential that is stored in Systems Manager parameter store in plain text secure form, and then have this referenced in the part of the application. Okay, here are some of the, the parameters already stored. For example, production database keys. Here the type is secure string, and the value is actually decrypted here. Away from visibility, there are two types of parameters, the standard tier and advanced tier. The difference between those two tiers is the amount of the number of parameters that can be stored and the size of the information that can be stored. You can move from standard to advanced and not the other way around, because once you have the information already secured of a different size, the standard one is for 4K size contents, and the advanced one is for anything more than 4K. So you can only go from standard to advanced, not the other way around. Okay. Let me quickly walk through of how to create the parameter. You give a name here. Choose standard and advanced. Standard says 10,000 parameters and 100,000 parameters, 4K size, and then 8K. Okay. You can choose between three different types, either of a string list secure, give a value, and then create a parameter. And once a parameter has been created, and if the application wants to refer this to communicate to the database, you can give this information, the ARN information of the parameter. Okay, that's the second option in the securing the data credentials. And the third one is the secrets manager. According to the workshop, it has some examples of how to create the secrets manager. The one advantage of secrets manager is you can do rotations, meaning on a periodic basis, you can rotate the secrets, but still the application can refer to this secret using the ARN, and this happens behind the scenes. Okay, this way the information that is stored in the secrets are not hard-coded in the application, just like the previous example. Okay, so those are the two different examples. You create a secret, and here are the different secret types, either credentials from databases from Amazon or even from any other database. You give the username, password. You can also encrypt it and then create. So this is the steps that you need to walk through. Choose the type, give the information, and optionally you can configure the rotation and finally create one. And just like the parameter store, you can actually reference this as a part of using the ARN. And you can also have versioning too. Okay. Finally, before concluding with the first level on the IAM, here are two references. In case the application secrets are exposed, how do you detect them, right? And that's where Amazon Code Guru Reviewer comes into picture. Here is a blog post of identifying the secrets, what's out there, either in your application or even in a public repository. Because this information is already published, I'm not going too deep. However, I'm referencing this in the description. At the same time, it's also referenced in the workshop as well. Okay, this information here, and it's also we will also refer you to this YouTube video, which identifies the hard-coded secrets using Code Guru Reviewer and how to protect them as well using Code Guru Reviewer. Again, this information is already available, so I didn't feel the need to recreate one more time. And however, I'm referencing this as a part of the workshop. Okay, that concludes the level 1 in this session. We will focus on level 2 contents of how to protect your data. Let's start with the first one. We'll go into 3 subcategories. First is focusing on the data that is stored in S3. There are 2 ways of how you can do this. The first one is at the bucket level. Okay. I'm picking one of the bucket here. Click permissions. And not too long ago, this information is turned on by default, block public access, which means that the information, once the bucket is created, it will automatically block all the public access. Okay. And here is the settings. We don't generally recommend this, but this is to indicate that this is turned on by default. Okay. This is a big security risk if you expose this, and so we want to be aware of this particular setting that is being turned on. However, in your account, you might have so many buckets, and you can do this at the account level. So block public access, and as you're seeing here, this block all public access has been turned on at the account level for all the buckets that's been in this account. This information is there, so there's additional layer of protection, even if one gets accidentally updated. Okay, and obviously when this gets changed, you should have some appropriate security measures to be notified and corrected immediately. So that's on the data protection in S3. Now, if things gets updated because of whatever reason is, one way to keep track is to continuously proactively keep a track of it, right? And that's done through CloudTrails. Who made the change? When was it changed, etc. And that's done through trail, creating a trail of events and sending it to S3. So this is the trail, creating a trail. You send all the output to your S3 bucket. It can be applied to the organization level. It can be enabled for all the accounts in your organization. Say you have AWS organizations and you have 10 to 50 or 100 AWS accounts within that. In your management account, you turn on this CloudTrail, enable it for all the accounts, and you designate a S3 bucket to have all the logs stored. This one obviously indicates that this encryption is happening, and also log file validation to make sure that the CloudTrail log files are also not tampered before it's sent to S3, right? There are two parts to it, creating a trail. If I give a name, by default, the management events are chosen primarily because the amount of management events are relatively smaller compared to data events. However, you still can choose the data event and what kind of data events needs to be tracked from S3, Lambda, or DynamoDB. If you choose S3, it can be, you still have further options to say whether it is for all current or future S3 buckets. And if it is Lambda, then you have different combinations, whether it is all functions or specific function, etc. So you try to limit and make it fine-grained so you have a control of the amount of data event that is being ingested. Okay. So if something happens, this is the first place that you go and look at it to see what happened and by whom it was happened and when, right? So the trail will list you the API calls that were done on all of these services. So it is relatively easier to identify the root cause of the issue with this information. The third piece in this protecting your data is the data can also be stored in the EBS volumes that are attached to the EC2, right? However, the people who create EC2 will pick pick an EBS volume at the time of creation. And there are instances where you have already volumes created and kept that can be attached. Okay. So imagine this situation where you want to enforce a situation where you want to encrypt all of your EBS volumes. And so it doesn't need to be tracked and have a management overhead at every step, right? Every time when EC2 gets created, you don't want to have a situation that to validate whether EBS volume is encrypted or not. So you can set this at the higher level, that is in the EC2 dashboard, data protection and security, and manage and say enable, always encrypt new EBS volumes, which means that any EC2 instance which will have a EBS volume attached will always be encrypted. So you don't need to have a validation done or some process and policies at each EBS volume level. Okay, one click will be done for all of the newly created volumes and snapshots. So now that we have the storage and now that we have the data as a part of EC2, the example workshop, the example in the workshop also mentions how we can protect the data in the database, and it takes an example of using RDS. Okay, in RDS, you can create, you can enable encryption at the time of creation. So when you create a database, you pick different options and you keep scrolling, you give several options along the way. And finally, in the advanced configurations, you give this enable encryption. Okay. Sometimes if the policy is not enforced at the time of this reading, say for example, some database were created unencrypted, what can we do that? And this workshop talks about very good detailed steps that I'm going to summarize in just a second here. Here are some of the databases that were already created, and I will show you one of them, database 1 old. We go to configuration, it says encryption not enabled, which means that this is a unencrypted database. So how do we make this unencrypted to an encrypted one? There are 4 steps in this process. Okay, the first step is creating a snapshot. For this, you go ahead, select the unencrypted database, and take a snapshot. Okay, that's the first step. And then once you create a snapshot, you come here and you will see a list of all the snapshots that were created. Okay. So several examples were created as a part of the demo preparation. And so here you are seeing unencrypted snapshots that were created. The second step is you have to select and create a copy of this one. Okay. So once a copy is created, you will see something like this, unencrypted database. When you create this copy, this is a time that you turn on the encryption. Okay, let me show you how. From unencrypted, I say copy snapshot. You give some name here, but here is where you will have the option of creating enabling the encryption. This is a step that goes from an unencrypted state to an encrypted state. Okay. Now that you have created the copy of the snapshot, the third step is go back to the database and choose the database that is unencrypted and say modify, and give a name that we say that it is an archive or a old or something like that, which means that this is a database, an older version of the database that was unencrypted. Okay, so you make a name, you make a note of the name and rename this one. That's the third step. And you apply immediately. And you click on continue, apply immediately. Okay. That's the third step, meaning we are archiving this current unencrypted database as reference. Then the fourth step is you come back to this snapshot and choose the copy of it and then restore. In the restoration, you will give a name of the original database that you originally had unencrypted. Okay. Because this database was referenced through different applications, you do not want to keep coming up with a new name. However, we are restoring back to the new old name itself. Okay. So that's a process here. So that's why in the previous step number 3, you save the old name so that it can be reused in this situation. So I'm going to summarize one more time of how to convert an unencrypted database to an encrypted one. You click the unencrypted one, you say take snapshot. You come to the snapshot. Once it has been created, come to the unencrypted one and take a copy. And during the copy, you make from the transition from the unencrypted to the encrypted one. Go back to the database, click on the unencrypted one, modify its name. Before modifying the name, make a copy or make a reference of the old name. This is helpful in the restoration time. Give a new name, just like as you are seeing here, as old or archive or whatever naming convention that your organization has, and then apply it. So at any point of time, whenever you want to recover or go to this database for viewing the contents, you still have a copy of it. So you're not completely deleting it. Then finally come back to the snapshot, pick the copy of the snapshot and say restore. Okay. So remember this 4-step process. I repeat it one more time. You can pause it. At the same time, it's already highlighted in this section very, very beautifully. Okay. And hope this walkthrough help in clearing out of how to convert this unencrypted database to an encrypted one. Okay. And finally, before wrapping the level 2, I want to highlight this particular article in the workshop that requires HTTPS for all the public web points, which means so far we have been talking about the data in various services, which means at rest in S3, EBS, RDS, etc. However, clients reach to your web application through various endpoints, and it can be several of them. It can be from Elastic Beanstalk, CloudFront, application load balance, or Amplify. So there are different procedures of how to enable the HTTPS and enforce them. The links here provided have detailed instructions for each one of them. If I were to expand this, go into detail in each one of them in this session, it becomes unusual long. That's why I'm keeping it to the minimum. However, if you feel the need to go through any one particular in certain priority, do drop in a comment in the section here, and I'll be happy to spin up a session just for the specific ones individually so that we don't run into longer sessions. Okay. And that brings to the end of this demo here. Let me switch to the presentation. Before we close out with the presentation, I want to highlight the references. The first one is the Security Baseline Workshop that we saw in the in the browser. The second one is a list of all the security offerings from my AWS homepage. When you land in this page, you will see all the offerings of various security services, and you can pick and choose which one you want to dive into much more greater detail. And finally, again, because this is a series, I have linked the part 1 of the workshop that we already have published here. Finally, I will wrap it up with a big thank you. Thank you for your time, and hope you found this session useful. And I will see you in the part 2, subcategory B of this series. Thanks a lot. Have a great day.